This video is to go over homework 3D, lesson 3.15, and number 4 says you have some apple cider in cylindrical pot that has the radius of 4 inch. You pour cider from the pot into a cylinder cup that has a radius of 1.5 inch until the cider in the cup is 4 inch deep. How much did the level of cider in the pot go down? So we have, first of all, we have a cylindrical cup with 4 inches, and we have two cylindrical pots. So we want to use the smaller one, which is the radius of 1.5 inches. We want to fill that up first and then pour into the pot so that we'll have 4 inch deep of cylindrical cup. So how many times we have to use this smaller cup to pour into this one? So in order to find that, you have to find the volume of the smaller cup and that, and then also compare the volume to volume of the 4 inch deep apple cider, and then you can start. Problem number 5. A square prism and the cylinder have the same volume. The side length of the base of the prism is the same as the radius of the cylinder. The height of the prism is 7 centimeters. What's the height of the cylinder? So square prism has something like this. So that should be square. The base should be square, and the height is 7 centimeters. And we have another cylinder which has the congruent radius. Another hint is that these two figures have the same volume. So, and also the radius and the side edge is exactly the same. So this volume of square prism and the volume of cylinder is exactly the same. So what would be the height of the cylinder and the base? You don't have to find the base. Yeah. Problem number 6. A factory has 3 cylindrical chimneys to release waste gases. Each chimney is 150 feet tall. The base of the chimney has a diameter of 15 feet. A can of paint can cover 100 square feet of surface. How many cans of paints are needed to paint the outside of all the 3 chimneys? So we have they have 3 chimneys, 150 feet tall and 15 feet radius. 150 feet, just like that. 3 of them. A can of paint can cover 100 square feet. So and you wanna paint the outside of that chimney. So how many of this can do you need to cover that? Cover the paint. So this is, you might want to find out the lateral surface area of the chimney, and 3 of them. And problem number 7. The factory in exercise 6 needs to install filters inside the chimneys. The filter completely fills the interior of each chimney. The thickness of each chimney wall is 1.5 feet. So the inside, there is a thickness of in the chimney, and that thickness is 1.5 feet. So if you look at that from the top, it'll be like that. So the inside here, the radius will be we have to find the radius of that inside the chimney so that we can find the surface area of inside. So the radius of the entire chimney is 15 feet. So minus 1.5, so the radius of interior of the chimney is 1.5, 15 minus 1.5, and then if you use that number to find the surface area, then you'll be able to, you can start from there. Problem number 8. Sean is making a replica of Washington Monument for history class. He decides to simplify the structure so that the replica resembles the square prism on the bottom and the square pyramid on the top. Okay. And what's the volume of Sean's replica? So you want the square prism on the bottom, and then you want the pyramid on top. And the total height of the replica is 24 inches, and the height of the pyramid at the top is 4 inches. So from here to here is 4 inches, and the length of one side of the square base of the replica is 3 inches, which is the same as these because it's square. Find what's the volume. So maybe you want to find out the volume of, separately. So find the volume of this pyramid and then find the volume of this square prism and then add it together. Problem number 9. Chef Jasper's signature dessert is an individual cake in the form of a right circular cone. The diameter of the cone is 3 inches and the height is 4 inches. We have a lot of 3 inches and 4 inches. I wonder why. What's the approximate volume of the carrot cake in each dessert? Find out. So the volume of that equals, if you remember, any cylinder or pyramid, it's 1/3 of base area times height. So you can find that out. So find the base area first and then multiply by the height and divide by 3. That's how you find it. Problem number 10 is actually take it further problem, so I'm not going to do it. So problem number 11. Terry wants to find out how much liquid a paper cup will hold. He measures the cup to be 4 inches high, and the diameter of the bottom of the cup is 2 inches. The diameter of the top is 3 inches. How many fluid ounces of liquid can the help hold? So it should look something like this, and so the radius is 3 inches. The top base of the radius is 3 inches, and the bottom is 2 inches. And we don't know how to find this, but if you know that this, if you look at this, is actually a partial. If you extend that the slant edge, this will be a cone. If you extend that, and it will meet some at some points. And once you find that, if you can find the volume of the big one, and if you subtract the small one, you can find out the volume of that one.